Hello. Today we're going to do some complex ion calculations. For this problem, I'm going to ask about sodium sulfate and I'm going to mix it with aluminum nitrate. First thing I do is I'm going to take the sodium sulfate and the aluminum nitrate and put them into a molecular formula. I have when I do the balance, I got 3 sodium sulfates, 2 aluminum nitrates, and that's going to react to form 6 sodium nitrates and 1 aluminum sulfate. I use my solubility chart to figure out that the sodium nitrate is going to be aqueous and the aluminum sulfate is going to come out and precipitate out as a solid. After that, I'm going to work through my complete ionic equation. And in this case, I have 6, so I'm going to break up everything that's aqueous. So I'll have 6 Na plus Aq plus 3 SO4 2 minus Aq, 2 aluminum, 6 nitrates, 6 sodium, 6 nitrates, and then the solid. When I work through this, I can basically cancel out everything that's the same on both sides, which is the sodium and the nitrate, and that will leave me with my net ionic equation, which is 3 sulfates plus 2 aluminums to give me aluminum sulfate. I'm going to use this chart right here to add my stuff that I need. You've already seen that I've grabbed my ions. I grabbed them from everything you see, which is orange. Everything I have circled or boxed or underlined orange is what goes in my table. So my sodium ion, my sulfate ion, my aluminum ion, and my nitrate ion. So once I've done that part of the table, I'm going to calculate the moles before, which means what are the moles before they're reacted? So when they're in their own beakers and before they've been mixed. To do that, I need to calculate the moles of each ion. To start, I'm going to take the 0.50 liters of 2 molar sodium sulfate. I'm going to multiply that together to get 0.300 moles of the sodium sulfate. When I dissociate the sodium sulfate, I'm going to get 2 sodium ions and 1 sulfate ion. That's the reason I take this 2, multiply it to my original number of moles to get 6 moles for my sodium ion and 0.3 moles for my sulfate ion. And those numbers I'm going to just place now up in my chart. So here I'm going to place, somebody get color here. So for my sodium, it was 0.600 moles. And for my sulfate, 0.3 moles. I'm going to do the exact same thing with my aluminum and my nitrate. And so I get 0.340 moles. There's 1 aluminum and 3 nitrates when I do the dissociation. And so on this one, I'm going to have 0.340 moles. And for my nitrate, 1.02 moles. The next thing I need to figure out is which is my limiting reagent, or which of my species gets used up first. So I have aluminum and sulfate. The ratio is 2 to 3. And when I work through the ratio, the sulfate is much smaller than the aluminum. Therefore, sulfate is my limiting reagent. As you can see here, I did a simple little cross multiplication to get this inequality. And so my sulfate is going to be afterwards all used up, so it's going to be 0. I then have to figure out what is my excess and how much is left over. So I take my limiting reagent, which is 0.3 moles of sulfate. I multiply it to get rid of the sulfates to leave me with the amount of aluminum. So that'd be 0.3 times 2 divided by 3, or 0.200 moles of aluminum used up. I then go back to my original amount of aluminum, which I found for my moles before up here, which is 0.34. And I subtract the amount I used up, the 0.2, and so I'm going to get 0.140 moles of aluminum left over. So this is going to be 0.140 moles. And then that leaves me with the sodium and the nitrate. So they're spectator ions and they don't change. So sodium and nitrate, they're not part of the reaction that forms the precipitate. So they remain the same. So their concentration, or the number of moles, will remain the same for them. So when we look to the moles before and moles after, this is still going to be 0.600, and this is still going to be 1.02 moles. Now to calculate my total volume, remember I'm mixing 2 solutions here. So when I'm mixing the two solutions, I have 0.150 liters and 0.200 liters. Because I'm mixing 150 mils and 200 mils together, and I make sure that's in liter form, that gives me 350 mils, or in the proper form, 0.350 liters. And it's the same for all of them because you're adding the two solutions together. To get the final ion concentration, I'm going to take the moles after divided by the total volume. So I'm going to take 6.6 divided by 0.35, I get 171. And we'll take the 0 divided by anything is going to be 0. I then going to take the 0.14 and divided by 350 mils again, or 0.305 liters. And for the nitrate, I'm going to take the 1.02 moles and divide it by the 350 milliliters again. So when I get that, I can plug it back up into my table. And so I'm going to get 1.71 moles per liter, molarity, 0, and then 0.400 molar, and finally 2.91 molar. So this is how you do a complex ion calculations. I hope this helped, and have a good day.